As some of you may know, when she came to her final demise, she said to Dorothy, "You cursed brat, look what you have done. I'm melting."
Bill Boynton of the University of Arizona, lead scientist for the TIGA instrument on the Phoenix lander. One could easily be led by some popular reports to think that this discovery of water is all Phoenix is up to. Not so. First of all, we've pretty much known about the water at least since Percival Lowell's days, but all of the lander's instruments are doing amazing work. Peter Smith mentioned during the briefing that they will soon begin using the atomic force microscope. It will provide 40 times higher magnification than we've seen so far. And the lander can boast of the most sophisticated weather instruments ever put on the Martian surface. By the way, you can see this sole's high and low temperatures on the Phoenix homepage. We'll have a link at planetary.org. Victoria Hipkin of the Canadian Space Agency is mission scientist for the Phoenix Meteorological Station. She presented data and images of everything from the cute little telltale that swings to and fro in the Martian wind to the light detection and ranging, or LIDAR, instrument. The green laser beam shooting straight up from the LIDAR generated one of the best picture shows of the briefing.
So this is absolutely an amazing image. What we're looking at here is essentially a laser light show on Mars taken with an instrument with the power of a 30-watt light bulb. And we are seeing that from 200 million miles away. You know, this is absolutely astounding. Now, you know, as well as being a very, very cool image, this is also a kind of a regular image in our atmospheric science data set in terms of what we're looking at. We're looking upwards. We've got the LIDAR beam in front. It's the first time we've ever done that. But behind it, we can see essentially a movement of the dust in the sky moving past the beam. This is at some kilometers further back. We're able to see the first 1.5 kilometers of the LIDAR beam as we're looking up in this steep angle, but we're able to see the background sky, and from the motions that we can see there, we can estimate wind direction at height, which is an important measurement for us. What we're also able to do with the combined LIDAR beam and the SSI image here is where the pixels overlap with the LIDAR beam, we can actually extract useful information from the SSI image that will help us with the composition of the particles, things like that.
That was Victoria Hipkin of the Canadian Space Agency, now a weather person for the northern Martian highlands. Our last taste of the July 31 Phoenix Lander press conference comes from Mark Lemon of Texas A&M University. Mark is lead scientist for the Phoenix Surface Stereo Imager, or SSI. This camera has already completed a spectacular panorama of the landing site. The montage was stitched together from 400 individual snapshots, taken at about 100 different angles. Sounds impressive, and it is. But it's nothing compared to the next panoramic effort planned for the SSI. This new montage has already been given a name that is in keeping with the mission fairy tale theme.
It's the happily ever after pan. It's the panorama that we'll sort of go out in style with. The first panorama we took was the minimum mission success panorama. We finished on Sol 3. The full one that I just showed is 100 times more data volume. The one that we are just starting in is 1,500 image taken through all geology filters at high quality, and altogether it'll be 2/3 of a gigabyte of data to transmit from Mars to Earth, which is nearly 100 orbiter passes. So this is the sort of thing where we'll take one very small section of it at a time and just add it up over as long as we can keep on taking this panorama.
Mark Lemon, lead scientist for the Surface Stereo Imager. When we return, we'll talk with the Planetary Society's Emily Lakdawalla about the latest news from the Phoenix lander and what we can look forward to as the mission continues. This is Planetary Radio.
I'm Robert Picardo. I traveled across the galaxy as the Doctor in Star Trek Voyager. Then I joined the Planetary Society to become part of the real adventure of space exploration. The Society fights for missions that unveil the secrets of the solar system. It searches for other intelligences in the universe, and it built the first solar sail. It also shares the wonder through this radio show, its website, and other exciting projects that reach around the globe. I'm proud to be part of this greatest of all voyages, and I hope you'll consider joining us.
You can learn more about the Planetary Society at our website, planetary.org/radio, or by calling 1-800-9-WORLDS. Planetary Radio listeners who aren't yet members can join and receive a Planetary Radio t-shirt. Our nearly 100,000 members receive the internationally acclaimed Planetary Report magazine. That's planetary.org/radio. The Planetary Society, exploring new worlds.
Welcome back to Planetary Radio. I'm Matt Kaplan. Emily Lakdawalla is Science and Technology Coordinator for the Planetary Society. Planetary geology is her number one field. That's just one reason she has been closely following the Phoenix lander. You can see her regular reports in the Society blog at planetary.org. Of course, you can usually hear her exploring every facet of solar system exploration in our Q&A segment. I asked Emily to provide additional insight into the news from the press conference at the University of Arizona, science headquarters for the mission. You'll also hear what she has heard regarding reports of so far unannounced data from the lander's MICA, or Microscopy, Electrochemistry, and Conductivity Analyzer. Emily, we just heard those excerpts from the media briefing. I'm going to start with really that very first comment from Michael Meyer, Chief Scientist of the Mars Exploration Program, saying that Phoenix has a new lease on life, or at least a small extension. Can this spacecraft survive for another, a month or so?
Yeah, the mission extension is through the end of the fiscal year, which obviously has nothing to do with the health of the spacecraft. The spacecraft has excellent power. The power situation is actually so good that they should be able to continue using the robotic arm right through the nominal mission and probably 2 months past the end of the nominal mission. So they're probably going to blast right on by that September 30th mission extension, going on up at least until mid-November. And what happens in mid-November is that Mars goes into solar conjunction, and it gets very difficult to communicate with Mars spacecraft from Earth. So we're going to have to wait and see what happens after November 13th is the date that happens. But I don't see any reason why the mission won't keep going at least until that date.
I wonder if we're going to get a chance to actually see this landing site become what Vicki Hipkin, the Phoenix meteorological mission scientist, she said it's going to be a winter wonderland.
Yes, I think so. And, I think that the mission team always hoped that they would begin to see signs of winter arriving to the landing site. And those are going to be, nighttime frost forming on cold surfaces. I think that we'll see a little bit of frost here and there. And if we're really lucky, we'll see that winter wonderland before Mars goes into the sun in November 13th. And then, I think we all hope that we'll be able to continue communicating with Phoenix after it gets out of solar conjunction, but I don't know if they're going to keep funding it after that.
Well, let's hope so. Speaking of Vicki Hipkin, that was a wonderful weather report she gave on the Martian Northern Highlands, and that video of the LiDAR experiment was
pretty cool.
Spectacular.
Yeah, that was pretty amazing. The video that they showed, the LiDAR, you actually can see 1.5 kilometers of it going up into the atmosphere, and you see dust blowing by. It's really an incredible movie. It's funny that meteorology is kind of a boring topic on Earth unless it's extreme weather, but on Mars it's what's happening. It's what changes from day to day or even from minute to minute at the landing site. So it suddenly becomes this very exciting topic.
Let's turn to what has been, of course, the biggest story that came out last week, and that is about the water, which, if you listen to our friends in the mainstream media, the story might be a little bit different from what was being communicated in the briefing.
Yeah, well, it's about the 20th time that water has been discovered on Mars, which is, yeah. They keep on announcing the discovery of water. It's not really what happened. We know that Mars has water on it. You can actually see the water on Mars with your backyard telescope. You can see the polar caps. But this really is a significant first. This week was the very first time that we have ever gotten instruments on that water. We are measuring and tasting and taking apart the water and the stuff that's dissolved in it with instruments on board the spacecraft, and that never has been done before. And I suppose if you're really a skeptic, you could always have said that white stuff was something else. It looks like water. It tastes like water. Well, now we know that it does taste like water, and so we know that it is in fact water on Mars.
And as I think Peter Smith said, it's the stuff in the water you just referred to, the stuff that's dissolved in it. In fact, I said to Sean Solomon the other day, a very different mission, hey, it's dirty water we're looking for, right?
That's true. It's dirty water we're looking for. We're looking for what's dissolved in it. We're looking for interesting things like perhaps organic compounds would be very interesting. But the other thing that we're